Okay. Sorry, the screen resolution on this is not great. You really can't see this. I knew better than to use a dark image as my first slide, but yeah, I did. This is the ruins of a space station. You can kind of see little bits and pieces there, cracked spaceship, space out behind it. And the reason for that is we're going to talk about building a universe in Perl. And I was actually going to give a talk about testing, but the organizer said, would you talk about Tau Station? You've been tweeting about it a lot. People are very interested in it. They want to know more about it. And then I found myself in the very awkward position of, I'm at a free and open source conference. How can I do a 40-minute talk about a commercial product without it sounding like an infomercial? That one's a little awkward. So I think I can actually pull it off. And by the time I'm done with this talk, you're actually going to see some things that you might want to bring back to your own code. So regarding questions, we only have 40 minutes. Quite often in FOSDEM, we run very short on time, unlike what you had just seen. So please hold your questions to the end, and I apologize for that. I know sometimes you want to interrupt because there's something you don't understand, but this time let us hold our questions till the end to make sure that we don't accidentally run over time here. So when I say the universe, what do I mean by this? So Tau Station is, you could say it's a text-based MMORPG. This is a little bit of a problem we found. When we say MMORPG, people tend to think game, which it is, but they also tend to think graphics. We've actually had one person ask, how can you be an RPG without graphics? And it's like, you never played D&D as a kid, did you? Or text-based. People say, oh, a couple of junior programmers can whip that out in a month. No. So that's why we say a universe, because we're trying to do something, we're trying to reframe the idea so that people understand it is bigger than, something simple like a multiplayer Zork, or a MUD. So, So it runs on both browser and mobile. We do a lot of mobile first design. We don't just make it for the web browser and resize it down for the browser, or for the mobile. We try and make the mobile actually work properly. And we also use progressive enhancement rather than graceful degradation, because graceful degradation is, well, crap, because people forget about the degradation part. Progressive enhancement means that we can build an accessible application. So I don't know if any of you are familiar with this problem with some facial recognition software. It often doesn't recognize people of color. Why? Because a lot of people who are not of color have been building these applications, and they don't think about skin tones or how they might look in the background. And so you see some things on YouTube and other places, look at this facial recognition app which doesn't recognize my face. Now, if you wrote to the developer and reported this as a bug, and they said, well, actually, black people are a really small demographic, we don't care about them, there would be an uproar. If you write to them and say, blind people can't use your application, and they said, well, blind people are a small demographic, there would not be an uproar because nobody cares. We're writing a text-based game. We actually think this is important. We do understand accessibility can be sometimes challenging for some companies to do for their applications, but we are trying to make this as accessible as possible. You'll see some examples so that blind people can use it. Or if you use a sip and puff device for navigating a browser, or just have a clicker, all sorts of things like that. We're trying to make sure that anybody can play this game, regardless of who they are. It's also free to play. I don't know if you're familiar with the free to play genre of games, but for the politics of some of that, we don't have level caps, we don't have pay to win. It's premium accounts, microtransactions, but anyone can participate. We want it to be as open as possible for everyone. And the story, I'm just going to kind of be brief about this. Basically, it's far future, around the year 2600, about 600 years in the future, humanity had a post-scarcity society, had spread throughout the galaxy, and then the attack happened. Planetary defense systems turned on the planet, airlocks were being invented, ships' reactors went critical, databanks were being purged. Most of humanity, trillions, were dead in a matter of hours. And then it stopped. And no one knows why. It's an event called the catastrophe. 2 generations later, humanity is restricted to a sphere about 40 light years across. They don't know how to build new technology anymore. They've lost a lot of that knowledge, but the old technology was robust enough that they can repair a lot of it. So if you want to try and force it into a genre, you can kind of think Mad Max meets Firefly. The universe itself, it turns out within 20 light years of Earth, there are 117 stars that we know of. That's an interesting caveat, because it turns out it's trickier than one might think. We have over 500 space stations, over 8,000 stations, so there's a lot of stuff. We're trying to build a universe here, not just a simple game where you just click and drool and whatever. The alpha, we're hoping to have it around the summertime. It's obviously going to be much smaller in the alpha. It's going to be invite for people who sign up on our website. It's only going to have 14 stations in Sol and Alpha Centauri. It should have about 200 areas, maybe 100 missions available for the thing. Obviously, some of the features are not going to be available at that time. That's just getting us an idea of the initial feedback on what people think about it. But we also have art, which, once again, you can't see very well. Unfortunately, I should not pick dark pictures for this. But because we believe, even though it is a text-based game, we also want it to be a very pretty professional game. So here's a character screen. This is not a mock-up. This is real from the game. You can see it looks fairly nice, fairly professional. It is a dark theme. After launch, we are going to have a light theme in there for people who prefer those. We actually track a lot of information. So here's a full character screen. I had to shrink it down so you can see more of it. That gives you an idea of the amount of information we might be capturing for your individual character. You might want to take a job. There's all sorts of careers available in the game. In the far future, obviously, jobs are going to be a little bit different. We have missions. Our mission system is non-linear, except for dialogue nodes is what we call a directed acyclic graph. For those of you on more of a comp sci bent, this is not like World of Warcraft missions. Go out, pick 10 flowers, come back. We have complicated missions sometimes where there's all sorts of things, and we don't always tell you what those other things are. If you get a mysterious package to deliver to Hervé in Nouveau-Limoges, we don't necessarily tell you that there might be something else you can do with the package. But there might not be. You won't always know. And this is actually a fairly simple mission. Some of them are just mind-bendingly complicated. And you won't always know because you'll just take a straight path to the mission. But we want to have that complexity available so people can enjoy exploring different facets of their character, making different moral choices, and some of them are pretty mind-bending at times. But as you do missions, you might get money, so you want to put your money in a bank because you might get mugged, people might take the money. And if you do get mugged, you might wind up in a sick bay, or if there's no sick bay in the station, you're going to fall back to your latest clone if you elected to get a cloning license. This helps you avoid permadeath, but does have other consequences, which I won't go into right now. You can relax in a bar after work. But it's space opera, it's sci-fi. You want to go to the stars, that's what you want to do. You want to travel around, you want to see what's out there. So you go down to the port, and you hop on a spaceship. Obviously multiple different types of spaceships. This, by the way, is a star map. I wrote this in JavaScript. I was pretty proud of it, and then our front-end developer said your JavaScript sucks, and they rewrote it. They were right. You can't tell from this, unfortunately, but the colors of the stars are astronomically correct. I keep wanting to say anatomically correct. That's awkward. The colors of the star are astronomically correct. We might actually punch up those colors a little bit because it's hard to see. But we think that's important because we do like to pay attention to a lot of little details. We won't say it's hard science fiction, but we're not offensive to science. This is what the star map looks like if you don't have JavaScript enabled, or if you have a screen reader or a text-based browser, because it's accessible. That star map is a useful thing that you can click on. If you just have a little clicker with your mouth clicking around, you're not going to be able to click one of those stars. So we have this available in text form. It's much harder to use, but unfortunately that's one of the trade-offs you have when you switch to a different medium. It is available for people who have various disabilities. The game's a work in progress. This is a game flow diagram of the port. Anything in red either is in progress or has not been started yet. So we're still working on the thing. And we might have to pull back some features because this shows like around April, the done date. You can see our burn down line is getting beyond that, so we're working on trying to fix that. I needed to explain that so you can understand the complexity, the scale of what we're doing. This is big, this is complex, and it is not like your standard apps. For one thing, it's very write heavy. Trying to build a write heavy database application is a little bit more difficult. But our guidelines is, first of all, we use proven technologies. We don't want to experiment. We don't want to take chances. There's some really, really cool applications out there that we've been looking at. We thought that might make things really fascinating. No. We want to make a product that's actually stable, that's robust, that people can use. We don't want the hype. So we stick with proven technologies. Very careful about our hiring. For our clients, we promise all of them they go through our software test, and they also go through what we call a structured interview to make sure that they have the skills, the soft skills that the client needs. And we do the same thing internally, hiring for Tau Station. It's just given us fantastic developers for the project. Very happy about that. And very strong testing. As most of you know, I have been testing a time or two. I care about it. I have a manifesto I call the Zen of Test Suites, which is out there. This is not yet on SlideShare. I'll get it up there so you can get the links later. So testing, I'll talk about that first just a little bit. I won't show you any of the code, but you'll get an idea of how we approach testing. So does anyone here use test class Moose? Okay, I see a couple of hands up there. Well, of course you do, Jeff. You're working on it. So test class Moose. Test class Most was a project that was released directly out of this project. Veer was the code name for it. So test class Most came out of that, and later on people kept asking me, how do I mix Moose and test class? Well, you can't, because they're both fighting over the constructor. So I just wrote test class Moose based upon my experience with test class Most. So those of you who are using test class Moose, and I know a lot of larger companies are because it's a fantastic testing framework, that comes out of this. So we're trying to give back to the community when we can. Even the code itself has to be closed source because we have to protect the secrets or else it ruins the gameplay. So that's a frustration. We'd like more to be open source, but we can't. Selenium's there, load testing. I wrote the load testing bots in Perl, and it wound up crashing my box before the dev server. So I wound up rewriting those in Golang, and now they will crush our stack quite nicely. Golang is really sweet, I might add. We have almost 11,000 tests at this point, and we track our test history. More people need to do this. I'll go into the test history in just a moment. So our test guidelines, I won't go over this. If you go out and you Google for Ovid Zen of Test Suites, you'll find it. But the test guidelines are very clear. We want our tests to be easy to write, easy to run, and they're really nice. And our test suite looks kind of like this. Oh my goodness. I won't do this again, I promise. Well, you will see it again in the presentation after this. I've learned my lesson. So that says 1,776 tests. That's not true. Test class Moose is an XUnit framework. And in an XUnit framework, you have test methods with a bunch of assertions inside of them. And the test method is considered a single test. In the Perl world, we have a test method with a bunch of tests inside of it. So we have a test report which comes out, which shows we have about 9,037 tests. If you add it up, that's around 11,000 tests, basically. And the report also shows us our slowest test classes and our slowest test methods, so we can keep an eye on where our performance bottlenecks are in our test suite. And the entire test suite, on a fast Linux box, you can finish it in about 5 minutes. Most people, it's around 8 to 10 minutes. But 5 minutes, I think, is rather interesting for 11,000 tests, because I remember when I first started for the BBC, we had a test suite of comparable size, and it took 1 hour and 20 minutes to run. Most of the time when I go into clients, they say, well, our tests, we're not running them very often, our test suite's broken. If they've got a test suite anywhere close to the size, it's taking them around 1 hour. That's awful. So we're not doing that at all. We've from day one, I said, that ain't gonna happen, and it's not. But you might wonder what's failing in your test suite. So we track our test suite state, and we run a little program called testfailures.pl, and it shows us all these test failures. So we can see the class. I've truncated some information so it fits. It'll show us the class that's failed, the name of the test method that failed, the date that it first failed, the date that it last failed, and the number of errors. And wow, that's a lot of errors we have there. That's actually kind of disconcerting. Oh, well, maybe I should just look at the test failures on master. So I restrict this to our master branch. We're using Git. And you can see the number of test errors the errors in our test suite for master branch have dropped dramatically. And actually, so you can look over here. 2 of those failures, you can't read it there, I apologize. 2 of the failures reference the leaderboard. So this allowed us to understand that our leaderboard is problematic. We've got a number of repetitive test failures there. We've looked at our leaderboard. We understand the problems with the code. So that's being rewritten in order to get around this problem. This is what tracking test state allows us to do. We don't forget about those past failures. But a lot of these last failures, the date's in 2016. So let me just look at the last 2 weeks. I have 4 errors in the last 2 weeks on the master branch, and it's testing respawning an NPC after they died. So, and actually we understand what that is. This is what this is why we pay so much attention to our test suite, because we want stuff to be robust, and we can check a lot of information over time. We also run this on our Jenkins box. So our Jenkins box also has an SQL-like database tracking all of the test failures over time. The major tools that we use, just about all of these are open source. The only one that's not is JavaScript. JavaScript is open standard. It's not open source, but it's close enough. So we're using Perl 5 version 24. It's very important that we have a lot of the modern tools available for us. Golang, that's just for our load testing bot. PostgreSQL, because we need a real database. Skitch for our database management. Redis is used just for caching. If our Redis server goes down, it would hurt gameplay but not kill it. It would slow things down. You'd lose a little bit of information, but it's not critical to it. Fluentd, Elasticsearch, Git, Jenkins, usual suspects. Nothing exciting about this list, and I think that's great because there's not a lot of risk involved in it. MVC, Catalyst, Template Toolkit, DBX class. Again, there's nothing exciting about this. We're very conservative in our approach to how we're writing code to make sure that we can actually focus on delivering a product and not debugging the latest thing and the greatest hype that just came out. But what does MVC look like for us? This is one of my greatest frustrations I have with tutorials for MVC. First of all, I'd like to see MVC renamed, Web MVC, renamed to AVC, Application View Controller. Because the model, I like to think of that more as an application, and then you have a controller and a view on top of that. Let me show you what I mean here. So here's one of our controller methods for the clone vat. So you go to a clone vat, you can purchase a new clone, and they will gestate a new clone for you if you have enough money and if you're actually in the clone vat. Very simple method. This is what we strive for in our controller methods. No logic. We do not want logic in our controller methods. More to the point, thin controllers, damn it. The reason we don't want logic in our controller methods is, first of all, when you write tests for that and your error is 500. What was that? Can I get a stack trace? Well, sometimes that's very difficult when you're going through, using mechanize or something like that to dig in there to find out what the actual error is. You have a whole layer of stuff which is irrelevant to the error in question that you have to dig through to get down to the actual error. So that makes it frustrating when you're testing. And also, it's hard to reuse the logic quite often that you have embedded in controller methods. Controller methods, just think of them as your API. You don't put logic in an API. It just dispatches between the view and the application. And in this particular case, if you purchase a clone, we don't have an independent page. We just give some messages back to the character, and we need to go back to the main clone vat page, so we just forward back to the index. Our controller methods, we strive to get them as simple as possible. And this is what a clone method can look like. Now, bear with me. I don't like to put a lot of code on a slide. I apologize for that. But let me walk you through this so you understand what's going on here. This is our clone method. First thing we do is we croak if they're not in the clone vat. Actually, we don't. We log the error. But basically, we have to make sure that they're in the right area in order to clone. We check to see if they have enough money. And then we start and end a transaction there. We remove the money from their wallet, and then we do the actual gestation of the clone. And then we send a message back to the character letting them know what happened. There's actually a number of problems with this, which I won't go into right now. But the biggest problem we have is, so this is the result you get back. You have purchased a new clone, how much it cost you, and then some narrative text about a clone swelling up in the clone vat or whatever. That is ugly code, though, because look at all of that. So this was actually in our clone class, and our clone actually shouldn't be rummaging around in the character's wallet. The clone class shouldn't be caring about the area of the space station that you're in. Clone class should be just gestating a new clone. There's a real confusing mix of responsibilities there. So, and plus, all of this stuff, if I'm doing another action, if I want to scavenge in the ruins, I need to check to see if I have enough stats, if I'm in the right area, all sorts of actions I need to do where this sort of behavior needs to be shared, and I don't want to write this code over and over again. So now, we have what we call economic exchanges. So this is what our clone method looks like now, getting a new clone. We check our steps. We assert the location is an area clone vat, wallet, pay, the price of the clone, and then clone gestate in that area. This middle thing is an area pay gestate. That's actually a method called on an economic asset. I won't go into details, but basically we have a declarative way of asserting all of these things must happen in this order, more or less, in order for this thing to happen. If any of those steps fail, it all rolls back. We typically don't even hit the database until we get to the end. There's a lot more stuff in there, such as, if it fails, do this, if it succeeds. But it's a much, much simpler way of writing this. And now I can share this self is an area clone bat, self is an area ruin, self is an area bar. I can share all of these behaviors very easily, and it makes writing new behaviors for the game trivial. So this was the old method. This is the new method. In fact, we probably want to fire the guy who wrote the old method, but that was me. So one of our devs looked at it and said, hey, that sucks, dude. And he came up with this, and it's a much, much nicer, much easier way of controlling the system. And this is also a lot easier to read on the right-hand side. It brings us to our next thing, though. You might be familiar with the concept of God objects. If you're not, for newer developers in object-oriented programming, they often tend to fall into the trap of creating a God object, which is where you're putting in way too much behavior into a particular class. That makes that class much harder to maintain. It's a frustration, and classes should follow something we call the single responsibility principle. If you have an invoice class, that just represents your invoice and your date, and that represents an order, which might reference a customer, which might reference the order of items. These are all separate classes and stuff like that. Everything has one and only one raison d'etre, if you will, and there should only be one reason to change a class. That's what we say for the single responsibility principle. But we had problems with this. So character purchasing a clone, every time I write a method on the character class, I'm pushing more behavior into the character class. So what we had originally was something like this. We were gestating this on our clone class, trying to pull behavior out of the character class and redistribute it to someplace else that it would be. The problem was, you might remember stuff like this, where we're checking if the character is in the right area, if the character can pay the right price. A clone class should just know how to gestate a new clone from a character. That's all it should know how to do. So we really shouldn't put all this behavior in the clone class, because who's responsible? This is an MMORPG. Your character drives all of the actions. Your character has a responsibility for all of this. And when we tried to avoid pushing everything into the character class, what we had was ugly stuff like this. So this follows a verb subject object syntax. Missions has missions for NPC character. No one could remember what that meant. No one. I wrote that. I couldn't remember what it meant. Every time I hit that, I would stumble across that. It was very frustrating. Whereas, if we go to subject-verb-object, and we try very hard to keep the subject-verb-object syntax within our code, we have if NPC has missions for character, no one is unclear about that, assuming they speak English or speak it well enough, they understand SVO languages. This is perfectly clear, but it means pushing the behavior back into the character class. So this actually makes our code easier to read than this convoluted syntax. How do we deal with that? Well, I said we don't like to experiment. I lied. Partial classes. I don't know if you're familiar with them. So imagine you have an IDE. And your IDE, you're designing a class in your IDE, and you have a particular attribute, and you annotate that attribute, and the IDE says, oh, I need to make a getter and setter for that attribute. So behind the scenes, it writes out some extra code, which it then composes into your class at compile time. And this extra code is a partial class. It might do this for a variety of things. A lot of code generators or compilers will use this technique to generate code that you don't see when you write the code, but gets composed into your class at compile time. And it's not something that humans generally do, well, until now. What I decided to do was this. A partial class sounds an awful lot like a role, which only gets applied to one class. So we have our role class, and now for your partial class character clone, we can purchase a clone, we've got our latest clone, respawn, we have our decants time. All of these are available in the partial class. In our character class, we apply a set of partial classes. These are single-use roles, not designed to be used anywhere else. And so you can see, you open up your character class and you can see it does clone, inventory, missions, movement. There's actually a lot of other partial classes that we have because this game is extremely complex. So what we've done is we've taken the different responsibilities of the character, and we have broken this down into partial classes. We've logically grouped them, and it turns out maintenance on this was trivial. It was really easy to do. Because we were using roles, this was giving us some of the benefits of static code that I won't go into right now, but it really simplified our code, and we were surprised. It was so much easier to maintain, and we're waiting for this to shoot us in the foot at some point, but it hasn't. So we're very pleased with that. Thank you. So let's move on to the next thing, though. Item design. This is the part where it really gets frustrating, because when you're building a business system, it's much easier to control the logical design of the things that you're building. So imagine you're trying to represent something closer to the real world, and you have armor, a combat suit. It acts as armor, but it also might fire back at the opponent for you, so it can act as a weapon. Or maybe you get hurt in combat, so it tries to patch you up, so it acts as a med kit. Or you get scared in combat, and it tries to whisper nice things to you to build your morale, so it acts as a psychiatrist. Single responsibility, my ass, pardon my language. How does that work? How do you model something like that? So, oh, that's just a picture of a medkit item. Sorry, that shouldn't be there. Entity component system. It is a pattern very commonly used in regular games. And basically, an entity is what we might think of as an object. Combat suit, handgun, medkit, etc. Components, different things it can do. It can act as a weapon, it can act as armor, it does movement. Entities have 0 or more components. So an entity might be as simple as having a name and a weight. Everything has a name and a weight. So that doesn't do anything else, but these are flavor items which are available in the game. Entities are data. They are not behavior. These aren't the way we typically think of objects. So how they actually work is in a typical game loop. While the game is running, we get our user input, we update the state, we draw it. What does update state look like? So maybe it's a game about animals running around in the forest. First, the animals tend to hide from danger to be safe. Once they make sure they're safe, they forage for food, then they move about, then they attack enemies. What does forage for food look like? For entity in entities, we iterate over our list of entities, and if is animal entity, search for food entity. Notice, entity, you're not calling a method on the entity. You inspect the data inside of the entity object to find out if it can behave like an animal, and then you call this method, or you call this function, passing it the entity as an argument. So the entities don't have behavior. They simply have state. But we're the web. We don't actually have a game loop. So iterating over all those entities can be extremely expensive in games if you have millions of entities, so they have all sorts of tricks for filtering stuff. We actually have something simpler because we don't have a game loop, so we just check the set of objects that we're interacting with at the time that you click on a thing, and complex behaviors become really simple. So let me give you a concrete example. So we don't do it this way anymore, but this is how we initially did it, and it's simpler to understand. So implementing ECS with a view, we select, the first thing is all the items, all the data that we need to select for a thing, which everything has, name, slug, weight, etc. We select our armor component, our mod component. A mod is like a bionic or genetic mod that you go to a sick bay and get installed inside your body. Weapon component, and then we do a left outer join on the tables containing that data. Why do we do a left outer join? Because if the data is not there, we get null results on def and Perl, and then we have predicate methods. We can see if it's armor to find out if the armor ID is defined. Is it a weapon? Is the weapon ID defined? And you might remember those economic steps we talked about earlier. Well, it doesn't have to just be the character as that first argument inside of a step. Here, we're going to install a mod in a sick bay. So location, we check that we're unconfined. You don't want to be in the brig or sick, confined to the sick bay. Then, bless you, then we check that we're in the area sick bay. We check that our wallet has enough money, and then inventory, the inventory object for this, we're going to install the mod, or attempt to do so. And the method, down here, we get to our predicate method if item is mod. And remember, we're just checking to see if the mod ID is defined out of the left outer join. That's how we can have rich, incredibly complex behavior on objects, very simply. It's not single responsibility. It does something a lot different from what we see from traditional object-oriented programming, but it works out really nicely. So when developers start on this project, most of them gush over it, most, not all, and they're really surprised. It's very, very clean and beautiful for production code. It's very easy to work on. I'm very happy about that. If you go out to taostation.space, you can see the webpage, and there's a blog link there, or you can sign up for the newsletter if you want to, and that'll give you a little bit more information about it. We actually haven't sent anything on the newsletter yet because we don't want to spam folks. That'll make you eligible for the alpha if you want to play. You can also follow us at taostation on Twitter. That's interesting because we're not just talking about the game. We're also sharing the latest science news, the latest science fiction news. If you're a science and science fiction buff, following this feed is just awesome. It's a lot of fun. And as usual, we have two choices now. I can A, take questions, or B, I have some bonus slides about some of the science involved. Every time, I love it. So has anyone here read the series The Expanse or watched the television series? Okay, cool. So a lot of times I see people complaining about one of the initial ships in the game called the Canterbury is an ice hauler going out to the rings of Saturn, mining ice, bringing it back. Water's ridiculous. That's kind of a joke. Why would you have ice mining? The average person in the Western world consumes a cubic meter of water every 2 to 3 days. And you think, no, I don't. I'm nowhere close to a cubic meter of water. Yeah, you drink, you flush, you bathe, you mop your floors, wash your dishes, watering the lawn. You go through a lot of water. Huge amount of water, and people don't think about it. So, just keeping the math simple, that's about 100 cubic meters of water per person per year. But a cubic meter of water, that's 1,000 kilograms, or a ton. Each of you goes through 100,000 kilograms of water a year. So 10 people, that's 1 million kilograms. We're supposed to have 80 people in this room. You're going through 8 million kilograms of water per year. Just the people in this room. That's a lot of water. How's this actually going to work on a space station? So let's assume we have 100,000 people on a space station. That's going to be 100 billion kilograms of water a year. If we were to hit 99% efficiency at recycling, and that ain't going to happen. I don't care how far in the future you get. It's not going to happen. That's going to be 100 million kilograms of water. And in case you're wondering, largest animal on Earth right now is a blue whale. That's about 700 blue whales worth of water. That's a lot, and that's heavy. For comparison, by the way, the International Space Station is 70% efficient at recycling. They were hoping to be 85% efficient, but they found a lot of the water they had was too acidic, so they couldn't get there. In the future, though, you're going to have a lot more space stations docking and undocking, or ships docking and undocking at space stations. The airlocks are going to open and close a lot more often. A lot of the water is going to be used as reaction mass and maneuvering thrusters. You will not hit 99% efficiency, but you're going to need a lot of water. So just for that small population, that's a small town, 100 million kilograms of water. That's assuming beautiful, beautiful efficiency at recycling. So ice mining is going to be a major industry in outer space. And as a result, it is something which we're going to be bringing to the game later on. It's not going to be in the alpha. But it's an important thing, and we do want to pay attention to the science. To calculate the orbital velocity of something, I've got this formula memorized at this point. What you do to calculate the orbital velocity of a satellite, this is the simple version, but it's fairly accurate. You take the gravitational constant, multiply that by the mass of the thing you're orbiting around, and then the radius is the distance of the item from the center of that mass. Note, you don't actually have to consider the mass of the item that's doing the orbiting. You just need the central mass. And for Tau Station, the primary space station, and the first space station in the game, it's orbiting around Mars. So we take the mass of Mars, multiply it by the gravitational constant. It's orbiting at a radius of about 11,000 kilometers. We multiply it by 1,000 because gravitational constants measured in meters. That gets us the velocity of the space station, and that turns out to be extremely important for our game. By comparison, so the International Space Station, orbital radius, almost 7,000 kilometers. The altitude is considerably different. International Space Station is 400 kilometers. Versus almost 8,000. Tau Station moves at 1.9 kilometers per second, which is actually really slow because the International Space Station is 7.66 kilometers per second and takes about an hour and a half to orbit. Tau Station takes almost 10 hours to orbit Mars. What that allows us to do, knowing this information, our get radians method up there. We have our elapsed time, which is the epoch, our current epoch, minus the epoch of the game. That tells us our lap time in seconds. We get the orbit time of the particular space station. We do a mod. Basically, you divide it. You just take the remainder. That gets rid of all the preceding orbits. Do a mod to figure out how many seconds in the current orbit you are. And simple math gets you the radians. And then for your x and your y, you pass in whatever date time you need. You get the radians, and you just use simple trigonometry to determine the current position of a space station. What that means is the cron job that I had written to update the position of space stations has been deleted, because now we can determine the position of the space station at any time on the fly, and space station data is now immutable, which solves a number of problems we had in the game. We do assume station orbits are, are circular, keeps things simpler, but it's fairly accurate. And this is important because we can now calculate the distance between two space stations. Again, simple trig. Because you want to travel a lot, and you need to know the travel time between the different stations. If you go to the port and you just refresh that page a few times, you'll see the price changing, you'll see the travel time changing, because we actually, again, it's stuff that we pay attention to. Even the information time, sending an email to someone else, we try to calculate how far away they are so that the email gets delayed. It's not going to be instant, because this is space. So that's the basics of it. I hope you enjoyed it. Does anyone have any questions?
Just one,
yes.
It's kind of the database system will have to sustain all that drives or actions.
What kind of database system?
Yes, because I saw that kind of joins. You have a lot of queries like that.
Okay, so behind the scenes, how do we actually handle that? There's a lot of joins. Yes, it's very expensive. So there's a couple of things we do. First of all, it's PostgreSQL underneath. We strive very hard to have a properly normalized database as much as possible so that we don't have to worry about the problems with that. And because the core item information doesn't have to change, you can cache that. So all of that is trivial to cache. Now, when you get the item and it gets inserted into your inventory, then it's no longer as easily cacheable, because the item might get damaged, it might get reduced. But primarily, it's just stuff that we can easily cache using Chai, and we use Redis as the backend for that. Which also means if that goes down, we can still go back to the database and fetch it. So you would lose some performance, but that's why we like immutable data as much as possible. It makes caching easier. Any other questions? Yes? Not at the present time. It is something that I had looked at from time to time, but no. So most of the time, for the speed at which the ships travel, and behind the scenes, we were actually considering like the G-force you would have when you were traveling. Relativity did not make a difference in most of those calculations, so we decided to not use that. That may change in the future. Are there any other questions? Yes?
Why Perl?
That's actually an excellent question. So I started this project back in 2010 and then got it dropped because I had a book deal and we had a brand new baby, and then we moved to another country, and those kind of interfere with things. But when I first started, I was thinking, well, maybe I should try something different, like, Rails or something like that. And then I realized, actually, I want to make a commercial product. I don't want to take risk on this. So it was a decision from day one that I want to stick with something that I know works, that I'm not going to be stuck wondering how I do this particular thing for a long time, because I didn't realize I'd have a large team behind me. So Perl works. It's rock solid. It's battle tested. It's been around for 25 years. And I don't have to worry about whether or not I can do what I need to do. It's going to do it.
But it hasn't been battle tested with large-scale games.
You're not familiar with Lacuna Expanse? There's a number. So, Booking.com is the 4th largest e-commerce site in the world. The entire backend, almost the entire backend, is written in Perl. Perl handles large loads. There's nothing unusual about that. Most of the performance issues you have with stuff like that are in your network or your database I/O, stuff like that. It's typically not CPU bound, so I'm not worried about Perl with that. Any other questions?
The last one.
Yes.
How do you manage to synchronize between user actions? So you have a user that makes a change in an item, and that affects another user. How you manage that? The problems with race condition?
The problems with race conditions there, most of that is how do I manage the user actions to avoid race conditions and stuff like that is what he's asking about, making sure they're synchronized. So some of it is simpler because you're in a different room, and if I'm impacting a thing, it's not going to impact you. Other items, it is we check to see everything that can be done, and then we have a transaction in as tight a loop as possible so that we try to avoid rummaging around in the database a whole bunch and, do a lock beforehand and then do a whole bunch of stuff. We try and keep those transaction times as small as possible. We did actually find a case where we had some locking in an unfortunate position, and that's part of the reason why I wrote the box in Golang to really smash it back to catch issues like that. So in this case, it's finding out what actually has a real impact in solving that.